So now we continue. Plus cos squared x times cotangent y times y prime is equal to 0. Okay, so now this type of equation is called this type of equations is separable differential equation. Now we separate the x's on one side and the y's to another side. So this becomes, firstly we take this guy to the other side. We have, so cos squared x times cotangent y times y prime is equal to minus tangent x times sine squared y. Now we divide by y squared and we divide also by cos squared x. We get cotangent y times y prime over sine squared y we continue now, minus tangent x over cos squared x. So this cotangent y is actually equal to 1 over tangent of y times 1 over sine squared y, and this y prime is actually dy over dx, and this is equal to, what is the tangent x? Is actually sine x over cos x times 1 over cos squared x. Then this becomes, remember that tangent x is actually sine y over cosine y. So 1 over tangent y is actually equal to cos y over sine y times sine squared y. All of this times dy, and we take this dx to this side. It becomes minus sine x over cosine to the third to the power 3 x times dx. And these two actually becomes cos y over sine to the power 3 of y dy, which is equal to minus sine x over cosine x to the power 3 times dx. Now we integrate both sides. So we take the integral of this guy, we take the integral of this times the equals minus the integral of this part. Now I think you know how to integrate those two. Sorry. So I will change the color to blue. So the first integral, the integral of cos y over sine squared y delta y. Notice that we could put, to do this, we have a change of variable. We will take u as sine y. So du, sorry, so du over dy is equal, what is the derivative of sine? It is cosine y. So this implies that, sorry, I so yes, so du is equal to cos y times dy. Hence this integral actually becomes du over u to the power 3, and this is actually equal to 1 over minus 2 times u squared. Now you return back to your our first variables. So this is 1 over minus 2, and the y and the u is sine u, and we have squared. Okay, by the same way we compute this guy. So the integral of sine x dx over cosine to the power 3 of x is equal to, take now t is equal to cos x. So dt over dx is equal to the derivative of cos, which is minus sine x. Now dt is equal to minus sine x times dx. So this integral becomes the integral of dt over, remember we have here minus, so it is here we have minus here, so it is dt over t to the power 3, which is equal to 1 over minus 2 times t squared, and we return back to our first variable. It is minus 2 times cos x to the power 2. So this becomes, I take this here, so the solution to this equation becomes, this is equal to 1 over minus 2 sine squared y, and this is equal to 1 over minus 2 cos squared x plus some constant c. Is that clear? I will continue. So we take both sides to, I will take this guy here, so we multiply both sides by plus, we multiply here by minus, it becomes this becomes plus, and this plus, and here we have minus c, and this minus c we could take it as k, and we take all to the other side, and we have 1 over 2 sine squared y minus 1 over 2 cos squared x is equal to k. And now we multiply all the sides by 2. This is times 2, this is times 2, and this is times 2. We get 1 over sine squared y minus 1 over cos squared x is equal to some other constant, name it c1 for example. And this is actually, what is it? It is the cosecant y squared y minus, and this times secant squared x is equal to c1. Okay, so this is the solution. If you write it like this or like this, I will consider them both true. So these are the solutions. So this is the general solution to the separable differential equation that we saw, which is tangent x times sine y squared plus cos squared x times cotangent y dy over dx is equal to 0. So